you guys. So the executive summary is basically an introduction. So what I'm going to be covering here. So we have multiple ways of malicious script execution. So let me actually maximize this on my device, and I hope that I'll be somehow able to. So, can I pop this out? Okay, that's good. At least I can. Okay, that is very good. At least I can minimize this or edit this to an extent, um, so that I see your chats, stuff like that. Okay, well, very good. So if this is an executive summary, which means that this is an introduction to the webinar topics, this one is a report based on the related or focused on PowerShell CMD, which is batch, C or net artifacts, net applications, artifacts, and other case studies. So there's going to be detailing everything that you need to know about memory, kernel analysis, as well as the script detections after incident, because that's what you guys really deal with. Otherwise, script detection would be actually easier than that. So we have the introduction to the digital forensics and incident response. Digital forensics and incident response, so DFIR, stands for the identification, investigation, or mitigation. So you retain this evidence of cyber incidents. Cyber incidents are cyber crimes and other types of activities that are directed at the that damaging some cyber or online or digital data. We have the blue team, we have the red teams. Blue teams are the continuous monitoring, threat intel, and defenses. So blue team forensics is the people who actually work for the detection of those threats, and anti-forensics are rather red team forensic teams. So those are that. We are blue team, yes, exactly. These drawings are specifically meant for blue team forensics. And then we have the shift left approach, which means that they incorporate um, digital forensics in corporate in corporate environments, which means that people actually hire digital forensic professionals to monitor their computers, as well as especially in corporate or um, uh, business environments. Because if you guys have no idea, there's this thing called um, this thing called cybersecurity, which basically every single corporation really employs and spends money on to actually have everything secure. Then you have the skill set for most of those types of shift left approach. That's because uh, they, they don't really necessarily they're not really necessarily digital forensic professionals, but they use the digital forensic utilities into controlled environments. So it's just they're shifting left. So you know, then you have the required skill set that you guys are going to learn at the end of this courses, especially. So those are the knowledge of OS internals. So those are utilities and how exactly Windows works. Memory forensics, scripting, and threat hunting. Memory forensics is something that we're gonna take a long time. Um, take a long time to actually dive deep into. This is rather a digital forensic for digital forensic source. They don't have the methodological frameworks, so exactly how exactly we're gonna analyze those things. We have the order of volatility, so capturing the most volatile data. I have these things defined and explained in the screenshot guide, in the 515 pages screenshot guide, so you can search up in this Learn Digital Forensics GitHub repository that I just showed you what exactly is highly volatile data, moderately volatile data, non-volatile data, and stuff like that. We also have the toolkits that we're going to be using. Those are the system terminals, Nearsoft, and built-in utilities into Windows operating systems. And then we have the automated collections. Automated collections in the for the purposes of screenshotting are obviously screenshot tools like Echo, Ocean, Storm, and stuff like that. We also have the closed loop processes. So Um, these refer to basically you identifying malware or identifying bypasses before they are routed and used into communities, so you are one step ahead of the bypassing environments. Then I have the executive, this is not really necessary for you guys to really read, but this one is interesting because I have listed some of the most important artifacts that you guys can use for the detection of execution, as well as not only file execution but also script execution. Prefetch is something that I have mentioned, and prefetch is also something that you can use to determine or build the timeline for when they have accessed. Previous webinar talking about the volatile data link files. Yes, link files are shell recent files, so the jump lists and recent docs that you see in the shell recent folders and subfolders. So all of these things help you identify not only execution of applications, so for example, scripted environments like Visual Studio Code, which is something that I have mentioned in my in the Discord channels. There is a guide about those things. You can also prove what scripts they used. So, because, for example, Visual Studio Code leaves residues or traces on the device for the scripts that the users have used. Uncached and cache is obviously the persistence of files after deletion. Then you have the jump lists. Those are important things because this also shows you if the user has accessed a scripting environment. And then we also have the event logs. Event log is actually a very important part, but this is not something we're gonna dive deep into as the extended course because it's not really that beneficial for you to, as beginners, creatures, to dive deep into something very advanced and very complex like event logs because this is actually a very large and vast topic. And then we have the link files for shadow copies and thumbnail caches that we talked about in the previous webinar, so you guys can basically review them if you have access to them. And then we have the forensic analysis of those types of environments. So there are 4 types of separated methods that I have given you. There's the analyze the command line arguments captured in logs. This refers to logs of processes, services, because, for example, Citizen1 service and process also can display the commands that the users have used. The most used method for script detection is to read the kernel live dump through kernel live tool that Spock made, basically. Because it has a lot of detections for scripts. And then we have the parent-child process relations through the initiation context, which this refers to there are scripts that, for example, in PowerShell, when you execute a script in PowerShell, the payload or the application is going to be linked to PowerShell because it is its host or a parent process. This is something we're going to cover. This is a very complex scenario, very complex topic, which we're also going to cover in the volatility and velociraptor analysis for that, just the forensic course. No, not the stuff you see on Virtue. I mean, if you are actually comparing those two, then I guess the parent file, so the PF file that you see at the top, can be the parent process or the parent file, and the loaded files that you see in the bottom window. Well, I guess you could say that it is like Virtue, but not exactly. So then we have the scheduled tasks, because most of the people use scheduled tasks to actually initiate commands. There are bypasses that schedule notepad.exe. So if you see that notepad.exe has established network connections, or even PowerShell has established network connections, especially PowerShell IC or Visual Studio Code, any scripting environment that has established network connections that you cannot verify, but you know for sure it's not supposed to be there. That can be enough evidence to plan for. We're gonna get to that, but I'm gonna say this. You can basically either use Zoom database analysis, that's first, because it also shows you that the files that have used network connections at what times. You can also use event logs. You can also use the firewall, Windows firewall, and you can also use registry. Well, in this case, I'm talking about registry explorer, not just any registry. And then you'll have to basically lots of artifacts. Yeah, there are a lot of artifacts, but you can also use tools like Nearsoft's uh, network connection view or something. I forgot what it is, but it basically parses Storm databases still, so you don't really have to use it. But it's easier to check Nearsoft tools for those purposes. And then you have the basic correlation of Windows events, as well as other artifacts. So, for example, now this is just a PowerPoint presentation to introduce to general theoretical ideas that you should be aware of or should keep in mind when you are basically. This could just leave. Oh my god. Okay. There's server actually. Okay, whatever. Yeah, his Wi-Fi just died. Okay. So anyway, okay, that's good. So anyway, go to the forensic analysis. Yeah, I also have forensic analysis for C. I also have for other things. In this case, we have the PowerShell history. We also have transaction logs. Transaction logs, if they are enabled, which they are not by default, so those refer to event logs that log um, PowerShell commands, which they're not enabled by default, but sometimes by filtering. I'll show you this actually. By filtering search indexer for transaction, you will be able to actually find some information that leads to script detection. So search indexer is also able to detect scripts, so the payloads themselves, but it is very situational. It is also varying, so it is very different from device to device. So it don't really work always, but I recommend that you do search contains case sensitive and transaction. This transaction is going to um, show you a lot of things. This also includes showing you deletions of files and the names of the files that have been deleted. And yeah, so this is some IDs and information that is very useful and necessary. Despite that, there's also memory compression, for the same purpose, this one also sometimes logs scripts and stuff like that. There's also Citrusmon. This one also sometimes logs scripts. There's also, obviously, there's DiveTrack, which the only way this is going to log scripts is if activities cache is enabled. Otherwise, everything is going to be encrypted or encoded. So to bypass that, you guys know that there's a smart screen for Windows. This is also sometimes going to show you scripts. The reason of smart screen is the purpose of smart screen is to prevent malware execution on the device, and there's also some mathematical calculations that Windows does when it analyzes and decides whether or not the code that you run is trustworthy or not. Primarily if those codes are also executed from Visual Studio Code. Which is why you can also find scripts in MSNPNG, this service. This service is actually quite useful because this one also gives you the data on connections. So those are the most useful artifacts. Although I'm also gonna get to the other useful artifacts. And there's PowerShell and SIMD. Not only those two, but anything executed on PowerShell, SIMD, Visual Studio Code, Batch. There's also VPS, so the macros, especially Microsoft Word macros, as well as Excel macros. So everything that can be executed on a device, because everything is scanned by the Windows system to decide whether or not the script is trustworthy. Things are getting very hard when it comes to when it comes to actual cybersecurity, because there is malware right now going on the internet that actually bypasses UEFI. It actually deletes the UEFI secure boot and infects the devices. So yeah, so it's also a very new thing. So then we have the execution policy settings and execution policy bypass usage. This is useful, very useful. So because most scripts do not actually execute on device, well, they can also just change the execution policies from the system itself. They can just find the execution policy modules. However, we know that most of the scripts that they use require execution policy commands, so this will be useful when you dump kernel live. So I'll be looking for the strings like execution policy. And then we have the PowerShell and remoting artifacts. So this one, remoting artifacts refer to services or applications on the device that aid in remote connections. So RTP, for example, but there's also VSM, which I don't really have. Yeah, so if you use Magnet Process Capture, um, you guys will be able to actually tell, if it's going to capture all of the processes. So all you guys will have to do is just scan them for strings and look for strings in those processes. Batch, so that it can be very useful to. I'm thinking about a method which I think I can show you guys for demonstration purposes. So you know that you can use Magnet Process Capture to actually create dump files, right? So the .dmp files. So after you've done this, what you should do is that you should open search everything, type .dmp, or go to the folder where all of those dump files are saved. Then you should export all of that, right? So you should just export the paths, save them as paths.txt. This is what Spock's tools use. And then you can use path parser. Or you can use path parser to immediately scan through all of the dumps of the device, looking for specific things. So I'm not doing that intentionally because you guys should develop, theoretical process. So you should visualize those before you do those. So I do recommend that you guys do still practice those methods on your devices. There's also system monitoring, script log logging, and telemetry for behavior detection. So these ones do not apply to screen sharing because this is rather for corporational monitoring of devices. So the servers of organizations, not really for you. And then we have the forensic analysis of C# and other compiled executables. We have the static analysis, obviously the analysis of malware. I showed you these for the digital forensics course. And then we have the dynamic analysis. You guys will be executing the malware yourself and analyzing the malware yourself, even if it means that you guys will be using system monitor, so sysmon or proc.dot, which monitors processes their changes. You can also recover closed processes when you are using it to monitor. You can also use Regshot, which just takes snapshots of registry and compiles them. And then with the memory forensics, so volatility or Velociraptor. And then you also have that DNS spy PSIF. PSIF is obviously process following detection, but it only works on running process following, so that are still on the device. Right, so that's the detections for other compiled things. And we have the memory forensics. You guys don't really have to read these, but I mean, I just recommend you still get used to memory forensics as well. The importance of memory forensics is also mentioned in this guide. What is the purpose of memory forensics? You just ask this AI, it's going to go through all of those files, sections, and it's gonna give you all the references that it found, and it's gonna rewrite what I wrote in those guides, and it's gonna then take you to my snippets. So it's it's a really useful thing that I've made so far, everybody to use. So it's very nice. Then have the forensic, anti-forensics, anti-evasion techniques. Anti-forensics obviously stands for concealing of the data or things that make, well, bypassing in your own language, but these make screen sharing or forensic analysis harder. For example, we have the secure deletion, S-delete. We have time stomping, we have log tampering, we have hackers, so files being packed, so obfuscated, encoded, encrypted. Sandbox detection, so when they detect if they are run on virtual machines. And then we have the fileless execution, which we talked about in numerous webinars. I don't want to repeat myself, so you guys can just actually go to those webinars over here and go to webinar videos. So you're gonna find fileless bypasses somewhere, including this one. Yeah, so for example, this one, fileless malware. You guys can just watch all of that and stuff like that. So the next thing we have the definition of time stomping, wiping, and log manipulation. Time stomping occurs when they modify the attributes of the device, of the application, so executable, to make it appear to have different time of or dates of modification, access, and blah blah, than they really do. So, for example, changing the date of prefetch for an application, which basically shows that the file has been executed months ago, when the reality it has been executed with Minecraft, let's say, in simple terms. We have the secure deletion versus simple deletions. Secure deletion, so S-delete, which people started to use now with recent bypasses, so I recommend that you guys also use this or attach this to your path parser and kernel live dump analyzer file sets Spock has made. This one carves. This one basically overwrites or makes the file irrecoverable, which means that user journal is not going to lock the file properly. It's not going to lock the file properly because what they do is that they nullify the bytes, they overwrite the bytes within the file itself. So usually instead of data extension and data truncation, it leaves simple, yes, like a zero fill. But they first randomize it and do that operation thousands of times, at least 100 times. But what they do is that these leaves a different trace at least 100 times. This leaves a different trace in user journal. It doesn't leave data truncation or data extension. It leaves very, very different traces. So that's why it becomes impossible to actually find the file deletion on the system, because the file doesn't get deleted. It just gets nullified, which is the same as turning a 100 megabyte file into 0 kilobytes, which means that it is basically deleted, but not really deleted. It just has been nullified. That's why those bypasses that say they bypass user journal, they don't bypass it. The issue is that their deletion is different from file delete. It doesn't show file delete in user journal. It shows something else, which we're obviously going to cover for digital forensic courses, not now. Then you have log clearing and fabrication. Obviously, this is just clearing logs, like for example, event logs and creating fake logs, and yeah, so stuff like that. So these solution to those three different ways of concealing data, so anti-forensic techniques, is to use multiple forensic tools. So, for example, if you want to prove that a .vps script was accessed or something else was accessed, you don't only use shell recent, you also use jump lists, and you also use registry, you also use shellbacks, for example. This one mentions thumbs database, which is the thumb cache. But as I said, you guys should not be using that for screen sharing. Then you have the advanced detection and sandbox detection, which is what anti-forensic tools use. So they pack the file, which makes it unreadable by human eye, if you know what I mean. So you can only, the binary of the file is going to be unreadable, so you'll not understand it when you open it, which is why you use like VirusTotal or other analysis tools. But even then, there are tools, for example, UPX. So let me write that actually. UPX encryption or encoding of files that makes it bypass even VirusTotal or other tools because of the way it is obfuscated. So it is an obfuscation technique, which I have also talked about in my other webinars, which you should have access to, because those are mentioned in Echo webinars. Another file is persistence in memory. Another thing about the files bypasses is that you detect them, some of them with WMI, which we're gonna cover later, but do not need that. I've already talked about anti-forensics 1,000 times in a previous webinar, so you guys can just watch them. Right, so then we have the case studies, which this is just a case study. You don't really need that. So this is an example of that of a vulnerable driver case, which overrode driver functions to plant malware. That's not really something you need to worry about. And then we have the validation of deployable code. This is also something that you guys don't really need to worry about, because this refers to corporational data. And then we have the code validation tools. These are the websites. These are the tools that help you validate code snippets. So in your case, you can just send me examples of code, and I'm gonna tell you exactly what it does, because I'm gonna analyze it for you. I was also trying to create a website that analyzes them for you. But that needed artificial intelligence, and I don't really have that much resources to do it. However, I just specified and found those types of things that help you verify the code. Then you have the advanced digital forensics. So these are the tools, basically. These are the tools that you guys can view. For example, even the TCP view, PS execution, so the program execution, and all of those tools can be useful for screen purposes. Then you have the sysinternals. So those are the tools. So Sysmon, autoruns. This is actually a very useful tool. You guys should also start using autoruns and TCP view very often, because they do help you with a lot of things. So this one has the persistence locations. So these is startups, for example, Windows registry keys, network detection, yes. Yeah. And then we have the, practical definitions. So this is for beginners. You guys don't have to really worry about this as much, because again, you guys can just read these and, understand what I'm talking about. Right, this one is something that you also don't have to worry about, because I already mentioned them previously. Then these are the recommendations. But digital forensic recommendations is just, for actual forensic analysis. So this also mentions the works that I have used. There are the definitions for fileless malware that operates primarily in memory without being persistent on disk. And yeah, so those are definitions. Those are the statistics. And yeah. Do you guys have any questions about the What bypass method is Poisson bypass? Is it? No, I'm pretty sure it is. But yeah, really, so those are the questions you should avoid asking right now, because especially first of all, it has been I have already held webinars at Ideco explaining that bypass. His bypass is encoded script and is also fileless malware. So yeah, to detect that bypass is actually, and I think they also use junctions. They also use junctions to hide them, but that's a very advanced topic that even if I explain it to you, you will never be able to detect it because you don't know the basics yet. So, do you guys have any questions about that specific PowerPoint presentation? I think common. No, it's not really that common. No, it's not really that common. I'll say that for sure. Yeah, you should really read everything. So there's another PowerPoint presentation that I wanted to show you guys. So this is the detecting the scripting interpreted execution. So obviously another the same topic. So we have several. So this is the ID of the scripting interpreter, which is the MITRE-ATT&CK ID. What this does is that it executes arbitrary code via command line or scripting engine. So, for example, scripts within PowerShell itself. Um, there are the sources for the detections, so file activity, process execution, network logs. I already mentioned that if you find like traces of Notepad or, for example, WinRAR or even Microsoft Word that is not supposed to be there, that means that they use something very suspicious. And then you have the detection queries and indications. Obviously, partial encoding command usage is something that you guys will be able to find through the Spox tools, especially the kernel tool, because you'll be able to add Microsoft Word injection as well. Yeah. This is actually something we also covered, but they started injecting into Microsoft Excel. Um, with Microsoft Excel. The only reason it works is that both of those have developer mode. So both of those tools, or not tools, but like utilities, so Excel and Microsoft Word have developer mode, which obviously allows them to execute commands in there. Then we have the partial chain, process chains. So, for example, you guys should really you should really analyze what's going on. For example, if you see WinWord being followed by PowerShell.exe or WinWord having PowerShell.exe in its loaded files, so in prefetcher, that is suspicious. So you should analyze all of that. Then you have the automation, obviously. You should use screenshot tools, and there's not much about anything in this presentation, as it's a very bland presentation. Um, so then I have made the rules that you guys can use for detections. For example, this one. These are the regexes that you can also put into System Informer search settings. This one detects strings indicating the encoded partial encoding command usage or base 64 payloads. For example, this one, these regex. I'm not sure that this is gonna work with helps and filers. Yes, exactly. These are the things that you guys can also add to your Ocean or add to your path parser or what's it called? Spox kernel lifetime or path parser because it allows you to add your own Yara rules, and you should do that. You should totally do that. Um, so let me see if this works with System Informer. I did not test this on System Informer, but I hope that it actually does something. because those regexes are designed for Yara to understand them. Okay, well, it does something, I guess. I'm not sure. MSN, PNG, for example. So if those don't work, tell me. I'm going to, yeah, okay, I don't really have access because I need to update this. So tell me if these don't work in actual inspections. You run the latest version. Okay, then imagine those is more updated than their system informer. So these ones are the Gara rules. These ones are the YAML rules. These ones are primarily um, for Sigma rules, chainsaw, event logs, as well as yeah, I worked on this. There's also these can also be used for those Raptor. Um, this one also can be used in system monitor, so sysmon. These rules are very important if you want to get in. There's also these ones. There's a scattered spider, which is a new thread found by, where is this? This is actually a report of the US government that they made. Well, I summarized it for you, but basically they found a new way of um, malware that also targets Zendesk. Right. So yeah. So I'm gonna send you guys these two. You guys can read their detections here too, because I also added those. But yeah, I think it's just yeah. So let me see. Okay, I also made those rules. Those ones are different. It's very new. It's very new actually. These ones are for the same purposes, but yeah, not fixed. It is fixed. It is fixed. And then you also have the extended course guide, which is the document version of something you guys will be able to read. Um, right. So these ones, for example, this is a WMI command. So which is a, for example, let me find this application. If you use WMI log viewer, can I do it? Is there a this is gonna work? I hope this is gonna work, but these are the applications you're gonna use to actually parse for those commands that I just um, I showcased. Let me see if I can get around with this. Your soft tools are always safe. You guys can always run them. I'm not sure how other players would really agree to that, but yeah. Okay. So you have this computer. Let's open this as can I open this as administrator? Okay. So let's say update. If I actually update, this is gonna log all of the processes and their creation commands and whatever they used for it. So what you have to do is just specify what exactly you are looking for. For example, the hardware, um, and then you should also update those reasons. This one isn't gonna help us because this just does nothing, pretty much nothing. This doesn't really show you much. There is a WMI lower viewer. I'll explore. It's this one, I think. Yeah, I think this is this one. Yeah, it is this one. This one's gonna help you with commands that I have provided because this actually allows you to paste them. Um, so let me see. Where do you download this? You download it from here, and then you need for 64-bit systems. the latest one, they also updated this. That's crazy. But yeah, it's 11 megabytes. Yeah, so you'll basically be pasting those, right? Pasting those into these lines. Let me show you. Right, so into these ones, the queries, the query, and it's automatically gonna find those traces that are useful for you. Also, this is something that I have talked about in the Echo certificates, so I think you guys can, well, if you, since you have it, you can view them in depth from those webinars and lessons. Okay, let's see. Do you guys have any other questions regarding the script detections? So the way you actually detect scripts is by, so first of all, you should have a general idea of what script you are looking for example, and then you should use the tools and artifacts that do have the potential to save those scripts. I have made some of them, and yeah, otherwise you guys wouldn't be able to really detect anything on scripts because CMD logs are not saved. Which is only the operations that are saved. So yeah, that's it about the webinar. By the way, that's pretty much it. We're gonna start the digital forensics webinar very soon. Um, so in 30 minutes. Well, I don't expect this to be so short because not many people attended, but it's okay. I'm gonna send them the course materials and stuff like that. Um, so let me see. Okay, so these ones are useful. One, this one should be. So we have these, these two rules. This one, script policy execution. I'm sure about this one. Is it? Yeah, okay. This one, this one. There's also scattered spider detections that I've made. And yeah, I guess I'm gonna just, send this here for the extended course. Voice very coming soon. Because I first have to close, finalize other things. Okay. Um, yeah, the webinar is over. Okay, yes. Could you send the message of this webinar? Yes. What to do with the recording? So you can send it to, so you can upload it on YouTube as unlisted so that others don't have access to it. Or you can also, yeah, and send it to me so that I can paste it in the webinar records so that others will might want to, uh, you know, do the things. All right. So that's all about the extended course. This one was an introduction. As I said, most of the topics that we are going through in depth right now have been detected already. We have already released a lot of things to the public as well. So all I can do right now is to go into in-depth logical analysis so that you guys develop a habit of thinking like a cybersecurity professional or at least an analyst. I'm gonna say that you guys are gonna become professionals because cybersecurity requires you to do individual self. Um, let's say you should dedicate your time to reading a lot of material, testing a lot of material. By the way, there's going to be a schedule in the core schedule, um, which is going to be about, by the way, about this anti-forensic deep dive. Um, yeah, I hope that you guys find this interesting because it is an introduction for the MFT secrets for the tomorrow's webinar. Um, so I hope that you guys actually attend that one too. Okay, with that being said, the webinar is over. Um, I sent you all the, is that tomorrow or in 30 minutes? This one is in 30 minutes because it's a digital forensics second. We also have another webinar in 30 minutes. MFT is tomorrow, yes, because it's a very large topic. And this is also something that I noticed that nobody ever explained and nobody ever showcased. So I think that it's going to be useful for digital forensic professionals. It's going to have a lot of material, by the way. This one, for example, today had 10 separate or 9 separate materials, although it is just an extended course. Tomorrow it's gonna be more than 10, probably. Not only more than 10, it's gonna be a lot of material tomorrow. So it's like, I know I said that these materials are gonna be more than 1,000 pages, but I think at this rate it's gonna be more than 1,500 pages or 2,000 pages of readable material if I keep this up every day. So yeah, there might be more content than I promised you guys. So there might be way more content than I anticipated. It's also going to be. So anyways, also said that we have these webinars are going to be in total in 3 months in total 108 hours. But we have already reached. Yeah, exactly. We have already reached at least 80 hours. Right, 80 hours. So I think even that is going to be uh, more than 100 hours. Okay, so now we're on a break for the next 40 minutes and see you guys on the other webinar. Because that one doesn't have any material. That's just me showcasing everything to you, because that's digital forensics. And then I'm gonna make material after the webinar. Yeah, it is practical. It is very highly practical. Yeah, so, okay. Yeah, that's it. See you guys tomorrow. Not tomorrow, in 30 minutes. Okay. I hope others will join too. So yeah.